Welcome to Oxford Real Estate Insights and our podcast on real estate research and practice, the Property Pod. I'm the AI voice of your host, Martin Schmalz. Today we have a special guest host, Cloé Garnache, from Oxford's Future of Real Estate initiative, who will be exploring a timely question in real estate technology. Why did companies like Zillow exit the iBuying market, and how can instant home buying work better? Our guest today is So Hye Yoon, a job market candidate in economics from Princeton University. So Hye's research examines the information challenges that iBuyers face and proposes innovative solutions combining contract design and artificial intelligence. In today's episode, we'll explore what really drove these failures, not faulty pricing algorithms, but fundamental information asymmetries. And we'll discover how revenue-sharing contracts and large language models could transform the iBuying model to achieve better outcomes.
Hello and welcome to the Oxford Property Pod, where we explore big ideas in real estate, one conversation at a time. So Cloé Garnache, I'm your host today, and we'll be discussing a topic that's the intersection of housing market, algorithm, and the economics of information. So over the past few years, you've probably seen headlines about iBuyers. So those are companies like Opendoor or Zillow offers, and they promise to buy your home instantly. So using a data-driven algorithm. And so what this means is that you don't need to get an expert, advertise your home. Those companies will make you an offer. It's a quick cash offer and a fast close. But then some of those companies started racking up losses, and Zillow famously shut down its iBuyer program, so citing unpredictability of house prices. So what happened? Was it the algorithm that was not performing well enough? Was it the model, the economics? And so our guest today has done a deep dive into precisely this question. And so Hye Yoon is a PhD candidate in economics at Princeton University. And her job market paper, Selling Fast or Selling Junk, iBuying Sustainable, brings powerful economic modeling and rich housing data together to unpack the incentives and information frictions behind iBuying. And so it's a paper that's been making the rounds, including the Economic Society and the Urban Economics Association, among others. And it's one of the most thoughtful, data-driven takes on this timely topic that we've seen. And so she shows in this paper that this iBuying model is not just a tech story. It's about how private information, selection, and contract design affect who sells to iBuyers and why. And so she offers not just diagnosis, but also concrete solutions, including a novel application of large language models to reduce information asymmetries in real estate. So whether you're a real estate economist, a housing policy nerd, or just curious about how data and incentives shape the future of property transactions, this conversation is for you. So hey, welcome to the Property Pod, and it's great to have you.
Thank you so much, and thank you for having me.
A pleasure. Thanks for making time in this busy job market time. So could you start by telling us a bit about yourself and how you became interested in housing markets and the economics of information?
Yes. Hello again. My name is So Hye Yoon, and I'm an applied microeconomist interested in industry organizations, real estate, and urban economics. So the reason I became interested in housing market is because housing market is really a fascinating area. Like on the one hand, is housing itself is really important, like networks for every household. And for instance, like when they're making a life decisions, is one of the biggest decisions for their portfolio, and they also have to pay mortgage. And because it is important for everyone, it's also important for government to make a taxation decisions or the regulation perspective. So on the one hand, I like it because it's very big market and it affects everyone's life. On the other hand, I like it because it has a lot of constraints inside. Like housing has constraints. It's related to my paper, but in a sense that individual sellers have facing constraints like time, logistical, or financial constraints when they're selling their home. On the other hand, there is a constraints of building new homes, facing a lot of regulations like zoning restrictions, and those all constraints and the liquidity of housing market itself, I think it creates the interesting questions in this field. So that's general reasons I like housing market. And for information economics, I like to see the problems in the of everyone's decision-making process, how they create the problem or the outcomes. I think information is always important in decision-making process. Like it's just like in some cases, information is very transparent. Like when I'm going to the market and buy some goods, I can see all the prices and information of the products. So in those cases, it's very transparent so that like people pay attention to the other things a little bit more. But in the other cases where information really makes the bottleneck, I think it's very interesting problems to see through. So that's where I'm enthusiastic about.
Yes, absolutely. For having, bought and sold homes, how do you know what is the market price? How much would you pay for a home? You're collecting information. What is the size of the home? How does it look? What is the quality? A lot of those dimensions are, and a lot of those variables are unobserved. What is the quality of the neighborhood, the schools, and so on. And so when you're selling, it's also, trying to find the best buyer. It's a really tricky business. And so I guess the follow-up question is, how do you choose? Do you choose to study iBuying? So recent tech-heavy development in real estate. What drew you to that research topic?
So the iBuying project is, I think, exactly the intersection was between my interest in housing market and then the information economics. Because at first I saw they started iBuying business very recently, and I thought that that's very interesting business model because they know that they have like better financial constraints or time constraints, so maybe they can provide liquidity in the housing market by making individual sellers to sell really quickly, like if they want to. But I also found that after 2021, 22, a lot of them really have big financial difficulties and some of them exited in the market. So I just wanted to know why it happens, and if I can provide the solutions from there, I wanted to provide the solutions based on the economic background.
Interesting. So diving more into your paper and the study, the question you're studying there, can you say more about what's the main economic challenge that iBuyers are facing, and how does your model help us understand this?
Oh, I'm glad to. So I try to view this problem through the lens of asymmetric information, which means that the imbalance of the information between what iBuyer has, what individual seller has. So I'm focusing on the two dimensions. The first dimension is the individual seller's burden of selling their home, like on the traditional market process. It's something like either financial, logistical, time, or emotional constraints. For instance, I'm really urgent to sell my home quickly. Or it could be also including something like emotional stress, that I'm stressed out when I'm hosting an open house, so I don't like random people coming to my house. So this is like all of the burdens of individual sellers, and I frame this as a hassle cost because it's a cost for them, like during the process. The other dimensions that I'm focused on is the quality of the house that individual sellers know about it. And then this doesn't include the quality that we can really easy to check from the websites, like the number of bedroom or the size of the house. There is a very subtle quality that is really hard to see just through the data set. Like if you think about the house, there is a natural light or the noise level near the house, or like maybe some houses have like interesting odor or not. So those kind of things are a little bit hard to observe unless you really walk through the house. So individual buyers and sellers during the open house period, they may know about those characteristics, but for the iBuyer side, they cannot really observe it quickly just through the data set. So this is the other asymmetric information dimensions that I'm focused on, and I call it as unobserved house quality. So Both are problematic in this case because they are both drive individual sellers to go to the iBuyer, but it's a little bit hard to just disentangle by their decisions because we don't know they come to the iBuyer because they're really urgent, or they come to the iBuyer because they thought there are some very bad unobserved quality that they want to hide. So I'm trying to disentangle that problem and propose the solutions based on that.
Yeah, so if my house, the bathroom is of poor quality, then I may not want people to actually come to the open house and inspect the bathroom, but I may try to sell it to the iBuyer who cannot assess the quality without visiting the home. So very interesting. Can you say more about the use of repeat sales in your data and basically how you're identifying the seller's decisions to sell to the iBuyer versus to, with a regular open house?
Yes. So so the entire process will be like this. The unobserved house quality that I defined earlier is more like house specific, regardless whom sell their house. So I define as like time invariant characteristics of the house. And for each house, there is a multiple sales over time. So I use the pre-iBuyer entry data, like using the multiple transactions on the same house to disentangle whether some unobserved characteristics is coming from unobserved quality, which is house fixed, or just coming from the market price risk, like which could be idiosyncratic over time. And then after iBuyer enter, I also search the another set, like not only the transaction price, but I also search like whether individuals sell their house to the iBuyer or on the open market. So using the choice informations, I identify like the size of the hassle cost and then how does it relate it to the unobserved house quality. So the baseline idea is like that with the estimates of the market transaction price and then estimates of the iBuyer offer price, I can see the expected price gap between market price and then iBuyer offer price. If the price gap is really, really large, but individual still goes to the iBuyer, that indicates the hassle cost for that individual will be really, really large because they have to bear a lot of discount to sell their house to the iBuyer. On the other hand, if it's very small, but individual still list their house on the market, it means that individual sellers' hassle cost is really small. So I use those two informations to identify the distributions of hassle cost as well.
Very interesting. Yes, those repeat sales seems to be key to really know that, I may want to sell to the iBuyer because I have my house is of poor quality, but from the previous sale that, yes, this house was from poor quality. Something that the iBuyer cannot do different sales together. Very, very, very. A bit about your counterfactual. So in the paper, you're looking at two types of counterfactual analysis where you're trying to basically improve the business model of those iBuying operations. So you're exploring both a revenue sharing contract and you're also using a large language model based on quality signals. Can you explain briefly how those work and what you find?
Yes. So the counterfactual have two different parts. Like one is from the contract design and the other is from using LLM to improve the precision of pricing algorithms. So the contract design part is just redesign the current 100% upfront payments to iBuyer reduces the upfront payments a little bit and begin to share the revenue contingently. So the basic idea from there is that if iBuyer starts to share the revenue, then individual sellers who knows that their house will have a much higher revenue on the market, they'll attract it more to the iBuyer later on. Individual sellers who know that their unobserved house quality is poor, they might be a little bit less attracted to the iBuyer. So iBuyer can have better selections. So it's coming from the arguments like insurance and a lot of asymmetry information literature. And I just use the revenue sharing and adding some technical details to make iBuyer do not overpay through that revenue sharing contracts. That's where the contingent means. to improve the iBuyer profitability. And then what I found from the evaluations using the house sales in the past few years after iBuyer enter, I found that when iBuyer reduces the upfront payments to around 60 to 70%, it begin to really have positive profits, and the overall profitability makes iBuyer more sustainable. So the other side is the using LLM part. There are a lot of unstructured data set in the housing market, and one of them is the public remarks from the listing agents. They explain the house in the human language, like how does this house looks like. For instance, they write something like, this house probably looks a little bit old, but if you go to the inside, it will be more spacious than you thought. So those kind of subtle and something that is hard to structure and standardize, I use the LLM to interpret and making more standardized characteristics. So on one hand, I just simply ask the LLM in their prompt, like, can you evaluate whether this will be a good deal or not, based on this human language text descriptions of the house. On the other hand, I use the fine tuning to make it to predict the actual price better, or I just put it into the LLM to get the sentence embeddings to get all embeddings that's related to house price. So in any of this approach, I try to create another variables based on this text descriptions of the house, and then adding that variable to the house price estimates for the iBuyers. And then in any applications, whether it's coming with the current iBuyer contracts or my counterfactual contracts, adding those characteristics improves the iBuyer profits, in any cases, and is especially more valuable when the upfront payments is really high, because it means that iBuyer cannot really utilize the incentive systems to make individual sellers to go to the iBuyer when they have better house. So in those cases, knowing more about the unobserved house quality is more important, and then LLM really have more valuable parts there.
Yeah, it's a very interesting application of AI to really, use the text to extract information, to extract quality signals. So we're running out of time for this podcast, but given your expertise, and all your work on AI and real estate, where do you see, how do you see AI as reshaping real estate and the housing markets in particular?
I think there's two different answers from there. The one is related to my work, because I think housing market has a lot of very subtle characteristics that is a little bit hard to explain the standardized data set. So one is, as I explained, the text listing descriptions. There would be something other informations like from image or the voice explanations from the agents. Those kind of characteristics were hard to incorporate into the research before the AI comes, because it's a little bit hard to standardize. But I think after using LLM, it might be easier to incorporate all of the subtle and unstructured characteristics to the housing market research. So I think it will be very valuable in that sense. On the other hand, I also heard from a lot of experts that data center is really important issues these days. I also talk with the data center managers in Princeton University, and they told me that the transition is really large, because before we just used many CPUs, and then the data center used around 5 megawatts for their current supports. But since AI needs a lot of GPU, and it needs to increase all of the electricity and then the power and then all other cooling systems to be updated largely, and then that creates the huge demands. So currently there aren't many supplies that meet all demands, and I think those makes the fields related to data center really interesting, and then something that everyone tries to focus on.
A very interesting segue on the citing of data centers and effect on real estate prices and energy use. We're running out of time. thank you so much, So Hye, for this discussion, for telling us about your paper, this really interesting research. This paper not only gives us, a clear lens on why iBuying has struggled, but also offers concrete, practical tools to make these markets work better. Thanks so much. We were very excited to have you, to this podcast with us, and really best of luck on the job market this year.
Thank you so much. It was really nice talking to you.
A pleasure. Bye-bye.
Bye.
That was So Hye Yoon from Princeton University sharing insights from her research on the economics of iBuying. She found that the challenges facing iBuyers stem not from faulty algorithms, but from fundamental information asymmetries that can be addressed through smarter contract design and AI-powered text analysis. So Hye's work demonstrates that with the right combination of incentive alignment and technology, instant home buying can become a sustainable part of the real estate ecosystem. Thanks for joining us on the Property Pod from Oxford Real Estate Insights. Don't forget to subscribe for more research insights on the future of real estate. I'm the AI voice of Martin Schmaltz, and we'll see you next time.